Our next lesson is called Solution Sets to Simultaneous Equations. So I want to start this lesson off with an opening exercise. It says, consider the following compound sentence. X plus y equals 10 and y equals 2x plus 1. What I'd like you to do right now is pause the video and answer questions A through F as your opening exercise. So you're going to circle all the ordered pairs, x and y, that are solutions to the equation x plus y equals 10. You're going to B, underline all the ordered pairs x, y that are solutions to the equation y equals 2x plus 1. Then in part C, list the ordered pair or pairs from above that are solutions to the compound sentence x plus y equals 10 and y equals 2x plus 1. Graph the solution set to the equations x plus y equals 10 and y equals 2x plus 1 on the same coordinate grid, and make sure to highlight the point or points that lie in both solution sets. And lastly, F, describe the solution set to x plus y equals 10 and y equals 2x plus 1. Once you have completed part F, you can restart the video in order to check the answers to the opening exercise. So again, at this time, please complete the opening exercise A through F. Okay, now that you had a chance to try the opening exercise, let's discuss. So A was circle all of the ordered pairs that are solutions to the equation x plus y equals 10. So you can see below, also in blue, I have circled 7, 3, 6, 4, and 3, 7. All of those have solutions where if I add the x and y together, I get 10. In part B, underline, which I did in pink, all the solutions to the equation y equals 2x plus 1. So you can see I have underlined -1, 5, 11, 2, 5, and 3, 7. So in part C, where it says list the ordered pairs from above that are solutions to the compound sentence, the key word here is and. Both have to be true. So we're looking for the solutions that you found that are circled and underlined. So the only one that is circled and underlined is 3, 7. And as a quick review, remember how we find these solutions. We're taking the x and y's, we're substituting them in, and we are seeing if it works or if it checks. So now that I know that, we go to part D, where it says graph the solution to each of the equations on the same grid, highlight the point or points that they have in both solution sets. So I organized my solutions from x plus y equals 10 into a table and plotted them. Again, you can see that was done in blue. Make sure you connect the points, arrows on the ends, and you label the line with x plus y equals 10. Then y equals 2x plus 1, I organized those solutions from above, remember those are coming from B, into a table. And I again plotted all of the points I could. 5, 11 does not fit on the coordinate grid, but we still have 3 other points that are easy to plot. So connect the points again, arrows on the ends, and label. There's no real world context around this. So it's okay to connect the points and go on infinitely in both directions. Lastly, it says in F, describe the solution set to x plus y equals 10 and y equals 2x plus 1. So you can see from above, the only spot I was able to highlight is the coordinate 3, 7. So the solution set was where the two lines intersect. So now we're going to move on to the example on the next page. We are going to solve the following system of equations graphically. And this time we'll go through the steps from beginning to end. As we've previously talked about, it's not an efficient method to continuously check XY pairs to see which ones work. So we're going to use our more efficient way of graphing here to get the solution to our system. So step 1, I've got to graph the first line. Step 2, I've got to graph the second line. They both need to be graphed on the same coordinate grid so we can see if they intersect and have a solution. So I will start with y minus 4x equals -1. Now, this equation is not currently in y equals mx plus b form, so we want to change that. So if I want y to be alone, I need to move the subtracting of 4x or the negative 4x away from that side. So I will do the inverse operation, which is adding 4x. Whatever I do to one side, I need to do to the other. So on this side, those x's cancel out and we get y equals, and on the other side, negative 1 and 4x are not like terms. So they're going to stay separate, and I'm going to write them in mx plus b form. So that would be 4x minus 1. Now that I'm in y equals mx plus b form, I can see that my slope is the number in front of x, which is 4 or 4 over 1. And if I think about slope, that's rise over run. My number on top is a positive 4, so that would be going up. My number on the bottom is a positive 1, so that'd be going to the right. My y-intercept is negative 1, which means the first point that I'm going to plot is 0, negative 1. If you're a y-intercept, the x value is 0. So I'm going to start at 0, negative 1 on the coordinate grid, and I'm going to go up 4 to the right 1. Up 4 to the right 1. When I try to do that again, I run out of space. So instead of going up and right, I can go down 4 and to the left 1. Down 4 and to the left 1. Then you will take your straight edge and you will connect these to form a straight line. Arrows at the end. And then you are going to label it with the original equation of y minus 4x equals negative 1. So that's graphing one equation. Now we're going to graph a second one. The second equation, y equals negative 1/2 x plus 8, is already in y equals mx plus b form. So I can write down my slope as negative 1/2. Only put the negative with one of the numbers, 1 or 2. I tend to put it with the top one. So to me, I'm going to read this as negative 1 over positive 2, which means I'm going down 1 and to the right 2. My y-intercept is 8, which means the first point that I'm going to plot is 0, 8. So I will go to my graph, plot 0, 8 first, and I am going to count down 1 to the right 2, down 1 to the right 2, continuously till I run out of space. If I'd like to get points in the opposite direction, instead of going down 1, I'd go up 1. Instead of going right 2, I'd go left 2. And once again, you are going to take your ruler or straight edge to create your line, arrows on both ends, and then you're going to label it with the original equation y equals negative 1/2 x plus 8. As we discovered in the opening exercise, the only place that's going to make the compound sentence or the system true is the point that they have in common, which is going to be the point of intersection. So I'm going to highlight that point. It's right there. So we can write then the solution to this equation below as the coordinate point of intersection of these two equations on the graph. So if I look, it's going to be 2, 7. Now, if I wanted to check to see if I was correct, which is not here in the notes, I want to just remind you that you have to do 2 checks. In order for this solution to be correct, it absolutely has to be able to check in both equations. So I'd take my coordinate, x is 2, y is 7, and I would plug it into y minus 4x equals negative 1 and make sure it checks. And then I would plug it into y equals negative 1/2 x plus 8 and make sure it checks. Now that you're an algebra student solving systems, you have access to your graphing calculator, and your graphing calculator can help you find these answers. So it says, how can I use my graphing calculator to find the solution to a system of equations? So I'm going to walk you through the steps here. The first bullet point says hit the y equals button and type your equations into y1 and y2. So automatically that tells you that these have to be in y equals mx plus b form. So if those equations are not in that form, you're going to have to get them in that form before you can type them in your graphing calculator. I'm going to go over to the graphing calculator now to go over the rest of the steps with you. Okay, now that we have the graphing calculator, I'm going to go to the y equals button, and I'm going to type in the first equation. You just want to make sure you typed in the transformed version. So that would be y equals 4x minus 1. So we'll type the 4, the x, and then minus 1. We will then go down to y2, and we will type in the second equation, which is y equals, then we've got negative 1/2. So I'll use my fraction template, number 1, to get 1/2 in here. Then type in the variable x and plus 8. So you want to get both equations in. Again, make sure that they're in y equals mx plus b form. Then we are going to hit zoom, which is the graphing key in the middle at the top, and we are going to choose choice 6 to get those lines graphed. Okay, so there is a picture of our graph. As you can see, it gives us a general idea, but it's still easier to plot by hand and see the accurate coordinates. But you can see that they're intersecting. And what's great about the graphing calculator is that it can actually calculate your point of intersection. Okay, so now we are going to calculate the intersection. We need to get to the calculate button, which is above trace. So you're going to hit second, trace, and you're going to get a menu. You want to choose number 5, which is intersect. Now, on my calculator on this iPad, it's asking me to pick a left bound and a right bound. On your graphing calculator, I believe it's going to ask you just if this is your first curve, is this your second curve, and then ask you for your guess. Either way, you have to kind of jump from line to line and hit enter to answer your question. So for me, I want to make sure I go to the left of the intersection point using my left arrow and say, yes, this is my left bound. You'll just hit enter if it says first curve. Then I'll go to the right of the intersection point, and you should also do the same. Make sure you're kind of near the intersection point. And I'm going to hit enter since that's my other side. And then if you hit enter one more time on your graphing calculator, it will give you the intersection point, which you can see here on my iPad version is 2, 7. So it's great that the graphing calculator will give you the solution at the bottom of the screen. And again, these directions are right on your notes to follow at a different time when you're trying other systems. So in the final part of our lesson, I want to review with you the 3 possible situations that can occur with a system of equations. So we're going to start with the first one, the one we've just been working on, which is one solution. This is where you're going to have 2 lines that intersect. So I'm actually going to write the system first. I chose y equals x and y equals negative x plus 3. So when we quickly sketch this out, we're going to have 0, 0, 1, 1, 2, 2. You're essentially going to have a diagonal line cutting across your coordinate grid. And then when I do negative x plus 3, I'm going to start up at 3 and go down 1 to the right 1. It doesn't necessarily have a nice answer, but I'm just sketching this out to show you this would be an example of one solution. It's crossing in one spot. Now, what about these equations are telling us that these will be one solution? So if we look underneath, what I want you to pay attention to here are the slopes. The slope of y equals x is 1. So m equals 1. The slope of y equals negative x plus 3 is m equals negative 1. So we are going to know from equations only because they have different slopes. Now, if I move to the middle, I want to show you what no solution looks like. Now, let's think about this. We just talked about the fact that a system has a solution, and the solution is where the two lines intersect. So if I'm not going to have a solution, that means my two equations, when I graph them, are not going to intersect. And the only way that will happen is if we have parallel lines. So I'm going to put parallel lines underneath. Now I chose the equations y equals negative x plus 4 and y equals negative x minus 1 when I ended up sketching them out. So up here I started at 4 and we have a slope of negative 1. So you can see it's going to look something like this. And then when I sketch the next one, it's still a slope of negative 1, but it's starting down here at negative 1 instead. So I'm going to have a line that looks like this. And you can see that those lines are never going to cross. That's because the slope for both of these is negative 1. So here you're going to notice by equation only, if you have the same slope but different y-intercepts. So they're going to cross the y-axis at different places but be slanted in the same way. And then finally, for our last one, we're going to have infinitely many. And these literally graph as the same line. So for example, if I had y equals 2x plus 3, I would start at 3. I'd go up 2 to the right 1, up 2 to the right 1, etc. And then just to show you with colors, if I switch to purple, if I had the equation 2y equals 4x plus 6, which is just double the pink one, and I were to actually get that in y equals mx plus b form, it's going to turn into y equals 2x plus 3. So it's going to land right on top of the other one. The way you can identify this by equation only is that they are multiples of each other. Or in other words, they're going to turn into equations that have the same slope and y-intercept. And so that concludes our lesson on solution sets to simultaneous equations.